In 1993, Porsche was losing money on nearly every car it built. Sales had dropped by 70% in just 7 years. And for the first time in decades, the company behind the 911 was in real trouble. And yet, right in the middle of that crisis, Porsche chose not to scale back, but to keep refining one of its existing cars. It was expensive, over-engineered, and made even less sense for a company trying to survive. At the time, it didn't look like progress. It looked like the final version of something Porsche was about to leave behind. Then it was gone. No farewell, no announcement. Production simply stopped, and Porsche moved on to a completely new direction. On paper, that was the right move. But decades later, it's that earlier car, the one built at the worst possible time, that people keep coming back to. So, why is it the car Porsche left behind that keeps becoming more valuable with time? And what exactly did they give up when they replaced it? That answer starts not with the car, but with the company that built it. In 1986, Porsche sold approximately 50,000 cars. By 1993, that number had fallen to approximately 14,000. Sales had dropped by more than 70% in 7 years. And the question inside Zuffenhausen was no longer about market share. It was about survival. The 964, which ran from 1989 through 1994, carried a significant share of the blame. It had arrived with genuine promise: all-wheel drive, coil springs, a more refined body. But quality had suffered. Warranty claims accumulated. The reputation Porsche had spent 3 decades building began eroding in ways that showed up directly in the sales figures. Wendelin Wiedeking arrived as chief executive in 1992. He brought in consultants from Shingijutsu, a group of former Toyota engineers who had worked directly under Taiichi Ohno, the architect of the Toyota production system. What they found at Zuffenhausen was a factory still operating on Kraft-era assumptions. Assembly time for a single 911 was running at approximately 120 hours per car. The Toyota consultants targeted that number directly. Through supplier rationalization, workstation redesign, and the elimination of rework loops that had become routine, assembly time was brought down towards 60 hours. That reduction was not cosmetic. It changed the cost structure of every car that came off the line. He reduced suppliers, tightened tolerances, and attacked the defect rates that had made the 964 expensive to own in ways buyers had not anticipated. Porsche returned to profitability by 1994. That car was the 993. The development brief was straightforward. The 964 had damaged Porsche's credibility in specific measurable ways, and a comprehensive redesign was not what the budget could support. So, the directive was simple: fix what was broken, don't rebuild what wasn't. The most dangerous problem was sitting at the rear of the car. The 964 had a habit. At the limit of adhesion, it would step out with very little warning. Lift the throttle mid-corner, and the rear end could rotate faster than most drivers could respond. The automotive press had documented it carefully, and it had become part of the 911's reputation in a way Porsche could no longer afford to ignore. This was not a new problem. The 911 had carried some version of this behavior since 1963, and Porsche had been wrestling with it for decades. The rear engine layout places the heaviest mass behind the rear axle. Under normal cornering, that mass generates rear traction. But the moment that traction breaks, from a lifted throttle, from a bump, from exceeding the limit, the same mass becomes the problem. It wants to continue rotating. Physics does not negotiate. Earlier engineers had developed what they called the Weisach axle for other Porsche models in the 1970s, a passive rear-wheel steering geometry that induced a slight toe-in under cornering load to stabilize the rear end. The principle was sound. Translating it into the 911's specific geometry, with its rear-engine weight distribution and its decades of accumulated chassis architecture, was the engineering challenge the 993 team inherited. The solution the engineers arrived at was the single most consequential decision in the entire car's development. The 964's rear suspension used a semi-trailing arm geometry. In normal driving conditions, it behaved predictably enough. But the geometry had a specific weakness at the limit. When a driver lifts the throttle mid-corner, weight transfers forward and the rear suspension extends. In the 964's semi-trailing arm setup, that extension changed the rear wheel's toe toward toe-out, pointing slightly away from each other, at exactly the moment lateral grip was needed most. The rear end lost traction, the car began to rotate, and the rotation happened fast because the rear engine's weight was already working against recovery. This is what the press called lift-off oversteer. The name is precise. The driver does not have to provoke the car. The simple act of releasing the throttle mid-corner is enough. The semi-trailing arm geometry interprets that weight transfer as an instruction to reduce rear grip, and the rear-mounted engine has enough rotational momentum to make the resulting spin fast and unforgiving. Period road tests documented it carefully. Car and driver, and road and track, both put language around it. The word that appeared most often was abrupt, not progressive, not gradual, abrupt. The 993's solution was the ILSA system, Lenkachse in German, a multi-link independent rear suspension where each wheel is located by multiple separate links rather than a single trailing arm. That arrangement gives engineers precise control over how toe angle changes through suspension travel. The target was specific, under the same lift throttle scenario that caused the 964 to step out. The 993's rear wheels needed to hold neutral toe or move slightly toward toe-in. Toe-in is stability-inducing. It keeps the rear tires generating lateral grip rather than surrendering it. The 993's rear end, under conditions that made the 964 rotate, would instead hold its line. Road and Track's 1995 test of the 993 Carrera confirmed the change immediately. The language shifted. The limit behavior was described as progressive, manageable, and genuinely more approachable than the car it replaced. The snap was gone. What replaced it was a rear end that communicated its intentions before it ran out of grip, which is the fundamental difference between a car that rewards skilled driving and one that punishes the moment a driver's attention wavers. The 911 had always carried a reputation as a demanding car. There is a difference between a car that rewards commitment and one that genuinely catches its drivers out. The LSA moved the 993 from the second category into the first. Approachable without being softened, precise without being forgiving of everything. The suspension was the most urgent problem, but the engine that had defined the 911 since 1963 was receiving its own final refinement. The engine in the 993 had been in continuous development since 1963. 30 years of refinement on the same fundamental concept. Air-cooled, horizontally opposed. 6 cylinders, mounted behind the rear axle. In the 993, that engine was designated the M64, a 3.6-liter air-cooled flat-six with 4 overhead camshafts, 12 valves, and Bosch Motronic engine management. North American output was 272 horsepower at 6,100 revolutions per minute and 243 pound-feet of torque at 5,000 revolutions per minute. Those numbers were never the point. What defines the M64 at a fundamental level is what it lacks. No coolant system, no thermostat, no water pump, no radiator, no head gasket in the conventional sense. Heat moves through finned aluminum castings into the surrounding air, supplemented by an oil cooler and the engine oil carrying a secondary thermal management role. The systems that account for a significant share of a conventional engine's failure potential simply do not exist here. The oil system is worth noting specifically. The M64 uses dry sump lubrication. The primary oil supply sits in a separate tank mounted in the right front fender, visible when the front luggage compartment is opened. The purpose is specific. A dry sump maintains consistent oil pressure during sustained high G cornering, where a conventional sump's oil can slosh away from the pickup and starve the engine at exactly the moment it is working hardest. The front-mounted tank also allows the engine to sit lower in the vehicle, reducing the center of gravity in an architecture where mass placement is everything. The M64's most significant refinement for the 993 was the Varioram variable length intake system. A butterfly valve in the intake plenum switches between 2 sets of runners of different lengths at approximately 5,000 revolutions per minute under full throttle. Below that point, longer runners build mid-range torque. Above it, shorter runners optimize high RPM breathing. The mechanism behind this is resonance charging. An intake runner of a specific length creates a pressure wave when the intake valve opens. That wave travels the length of the runner, reflects off the plenum wall, and arrives back at the valve at a specific moment in the engine's cycle. If the timing is right, the returning high-pressure wave arrives just as the valve opens again, effectively supercharging the cylinder with atmospheric pressure alone. The optimal runner length for that effect changes with engine speed, because the timing of the pressure wave is a function of both the runner length and the time between valve openings. Varioram gives the M64 two tuned lengths rather than one compromise. The transition at 5,000 revolutions per minute is audible as well as physical. The engine note changes character at that point, a shift in harmonic frequency as the shorter runners alter the resonance of the intake tract. It is not a dramatic sound, but it is a specific one, and once noticed, it becomes one of the defining sensory markers of the M64 at full throttle. The Varioram's purpose was never peak horsepower. It was broadening the useful range of the power curve. Period tests returned to that quality repeatedly, not the headline numbers, but the character of how the power arrived. One detail buried inside the M64's architecture matters enormously to what comes later. The intermediate shaft, which drives the camshafts from the crankshaft, rides on a roller-type bearing. That bearing type and its significance will become clear when the car that replaced the 993 is examined. For now, it is enough to note that the choice was made, and that it was a different choice from the one Porsche made in the engine that followed. The 993 Turbo operates in a separate category. Its engine, the M64/60, shares the air-cooled flat-six architecture, but uses different cylinder heads, different camshafts, lower compression pistons, two KKKK2-4 turbochargers, and a specific intercooler system. Output was 408 horsepower, with all-wheel drive and the turbo's wider body. Calling it a boosted Carrera understates the engineering gap. They share an ancestor. They are not the same machine. But within the 993's production run, the Turbo and the Carrera were not the rarest cars wearing the badge. Those belonged to a much smaller group. Porsche produced 68,029 examples of the 993 across its entire production run. The 996 that replaced it produced more than twice as many. The 997 after that produced more than 3 times as many. Scarcity, in the 993's case, is not a vague impression. It is a specific number, and within that number, there are smaller numbers that belong in a different category altogether. The 993 Turbo S was the highest specification factory variant, approximately 183 units, all markets combined. The Turbo S used a higher output version of the M64/60 twin-turbo engine, producing approximately 450 horsepower, added a fixed rear wing, and stripped the interior of sound insulation in favor of carbon fiber trim. It was a factory-built performance specification, not a dealer package or an aftermarket conversion. Then there is the GT2, approximately 57 units total, rarer than the Turbo S and more demanding than anything else in the 993 lineup. Porsche built it specifically to satisfy GT2 class racing regulations that required rear-wheel drive, which meant taking the twin-turbo engine from the AWD Turbo and routing all of it through the rear wheels alone, in a rear-engine car. The limit behavior that implies is not for the unprepared. It was not sold through normal North American channels. The Carrera S and Carrera 4S offered a different proposition. The Turbo's wider body, but the naturally aspirated Carrera engine underneath. The visual presence of the Turbo without the twin-turbo powertrain. A genuine distinction, but a quieter one. And then there was the Targa. The 993 Targa eliminated the structural Targa bar entirely, replacing it with a panoramic sliding glass roof that opened the full roof area while retaining the structural C-pillar. That bar had been a visual signature of the body style since 1965. The 993 removed it. The 911 community divided on the decision, and when the next Targa arrived, the bar came back and has remained ever since. The 993 is the only generation in the lineage without one. Porsche never announced that production was ending. The variant simply stopped being built. The 996 arrived, and everything changed. The 996 arrived for the 1999 model year. New body, new interior, new engine, water-cooled, for the first time in the 911's history. The transition had been in development concurrently with the 993's entire production run. 3 specific pressures made it inevitable. Emission standards were tightening in ways an air-cooled engine's thermal management could not reliably meet. Water cooling gave engineers precise control over combustion chamber temperatures, which meant cleaner combustion and compliance numbers a modern market would accept. The second pressure was acoustic. Coolant keeps temperatures uniform across engine components, which allows tighter manufacturing tolerances, which reduces mechanical noise. The 996 was noticeably quieter than the 993, and in a market where refinement had become a competitive measure, that mattered. The third pressure was output potential. Air-cooled combustion chamber geometry is constrained by the need to move heat through finned castings, which limits how aggressively the chamber can be shaped and what compression ratios are achievable. Water cooling removes that constraint. The path to significantly higher output in future generations was far more accessible with the M96 architecture than anything the M64 could have provided. The 996 launched at approximately $65,000 in North America. Newer platform, more power, lower noise, lower price. On paper, the case for spending more on an older 993 was not obvious. The details told a different story. The intermediate shaft in an engine drives the camshafts from the crankshaft. Its bearing sustains continuous rotational load for the engine's entire operating life. A roller bearing carries that load through line contact across the roller's length. A ball bearing carries it through point contact. Line contact distributes stress across a larger surface area. Point contact concentrates it. Under sustained load, that difference determines how long the bearing survives before it fails. The M64 uses a roller bearing for the intermediate shaft. The M96 in the 996 that replaced it uses a single-row ball bearing. The M96's ball bearing began failing at lower mileages and with higher frequency than anything in the M64's documented service history. When it failed, the consequences were not a repair item. The intermediate shaft loses support, camshaft timing collapses, and the engine destroys itself from within. Specialist press documented it. Independent engineering assessments confirmed the mechanism. By the early 2000s, the M96's intermediate shaft bearing failure was an established liability attached to the car that had replaced the 993. The M64's roller bearing had not failed at the same rate. The engine the market had moved past turned out to have made the more durable choice. In the early 2000s, a used 993 Carrera could be bought for less than its original selling price. The 996 was newer, cheaper, and carried Porsche's current engineering behind it. The case for spending more on an older car was not one most buyers were making. Then, the IMS bearing failures accumulated. First in specialist forums, where owners compared notes and patterns emerged. Then in the independent press, where technicians put language around what they were seeing. By the mid-2000s, the M96's bearing failure was not a fringe concern. It was a documented liability attached to the car that had replaced the 993. Well-maintained 993 examples began trading above their original selling prices. R.M. Sotheby's, Gooding & Company, and Bring a Trailer all produced sale records showing consistent appreciation across 2 decades. The data was not anecdotal. It was a price history, recorded transaction by transaction. The Ferrari 355 is the useful comparison. Similar vintage, similar market positioning, its own devoted following. Ferrari 355 values appreciated over the same period, but not at the same rate as the 993. That gap isolates the specific driver of the 993's premium. It is not that mid-1990s sports cars became desirable generally. It is that the last air-cooled 911 appreciated at a rate that reflects a specific mechanical advantage over its successor, priced by a market that understood exactly what it was buying. Porsche's Classic Parts program confirmed what the transactions were already showing. The factory continues producing or sourcing components for the 993 specifically, a formal commitment to parts availability documented in Porsche's own program materials. A Ferrari 348 or Lamborghini Diablo of the same vintage does not have equivalent factory support. The 993 does. That institutional backing added a floor beneath the collector premium that sentiment alone could not have provided. Start with the body, because the body is where the forensic argument is clearest. The 993 uses a fully galvanized steel shell. Every panel, every floor section, every sill and wheel arch coded in a process Porsche had been refining through the 1980s. The 993 represents the fullest expression of that program in the air-cooled era. Porsche did not simply build it that way and hope. They wrote it down. A 10-year perforation warranty against body corrosion, documented in the original owner paperwork. Not a press release. A legal liability the factory formally accepted at a moment when the company could not afford to be wrong about anything. A warranty is a financial instrument. It is a company stating, in writing, that if this specific thing fails within this specific window, the company pays. Porsche calculated the failure risk of its galvanization program and accepted that liability while still clawing back from near bankruptcy. That is engineering confidence expressed as a legal obligation. The survivor population confirms it. Well-maintained 993 examples in salt belt climates, cars that have spent decades in environments that dissolved comparable Italian sports cars from the floor pans up, show body integrity at 25 years that no Ferrari 348 or Lamborghini Diablo of the same vintage can match without extraordinary intervention. The floor pans hold, the sill sections hold. The wheel arches, which consumed earlier 911 generations through the 1970s, hold. The galvanization worked exactly as documented. That durability came directly from what Wiedeking built at Zuffenhausen from 1992 onward. His lean manufacturing program attacked specific defect rates, reduced the supplier base, and tightened tolerances in measurable terms. The 993 was the first 911 produced entirely under that program. The 993's NHTSA complaint data for its North American production years is sparse relative to what the 964 generated. Warranty claims were a fraction of the prior generation's cost. The improvement is not a perception. It is a documented shift in the defect rate of a physical product, readable in warranty records and regulatory complaint data. The 993 carries two historical endpoints simultaneously. It is the last air-cooled 911, closing a lineage that began with the original 901 in 1963. And it is the first Porsche of the modern manufacturing era, the car that proved the turnaround had worked. Both facts live in the same vehicle. The 996 arrived with genuine advantages in emissions compliance, acoustic refinement, and output potential. But it also arrived with an intermediate shaft bearing made from a less durable material than the one in the engine it replaced. The ball bearing in the M96 was a cost and packaging decision. The roller bearing in the M64 had been an engineering one. That distinction illustrates the difference between a car built to be the best version of what Porsche knew and a car built to launch a new era at a price the market would accept. The 993 did not know it was the last of anything. Neither did the engineers who built it. The brief asked for a corrected, refined, durably constructed evolution of the 911 they had inherited. That the result became the final expression of a 35-year engine lineage was the accident of timing. That it became the most structurally sound, mechanically durable, and historically significant 911 of its era was the consequence of the decisions made inside that brief. A Porsche mechanic with 20 years of experience in 1998 had worked on air-cooled flat sixes from the 2.0-liter 901 through the 3.6-liter M64. 35 years of continuous development on the same fundamental architecture, accumulated in specialist hands worldwide. That depth has no equivalent in European sports car service. It is why a 993 with a documented history and a competent specialist is a different ownership proposition from a Ferrari or Lamborghini of the same era. The parts exist through Porsche's classic parts program and the independent network that followed the market upward. The knowledge exists. Porsche made no announcement when production ended, no farewell edition. The line stopped and the 996 began. The significance was assigned afterward by the market, once the 996's problems clarified exactly what the 993 had been. The car became worth more because what replaced it revealed what had been lost. In 1993, Porsche was losing money on nearly every car it built. The engineers who developed the 993 were not chasing legacy, they were chasing survival. The brief was not to build something memorable, it was to fix what was broken, and do it without spending money the company did not have. What they produced under those constraints was the highest expression of 30 years of air-cooled development, a fully galvanized body backed by a legal warranty, a roller-bearing intermediate shaft that outlasted the one in the engine that replaced it, a multi-link rear suspension that solved a handling problem 3 decades in the making. None of those decisions were made to impress collectors. They were made because the engineers doing the work had not yet been told to compromise. That window closed, it always does. The accountants arrived, the platform changed, and the bearing that mattered most was sourced to a different specification. The 996 was not a bad car, but it was a different kind of car, one built to open a new era at a price the market would accept, rather than to close an old one at the standard it deserved. The 993 sits at that exact boundary, the last car built entirely from what Porsche knew, before the pressures of a new era reshaped what Porsche was willing to do. Cars like that do not get made twice. The conditions that produced the 993, a company fighting for its life, a manufacturing culture being rebuilt from the ground up, an engine lineage at its final and fullest refinement, those conditions existed once. The 993 is what they produced. The market has been saying that ever since, transaction by transaction, in a price history that does not require interpretation. If this kind of story is what you come here for, there is another one on screen right now. In 1989, Toyota handed engineers a blank check and told them to chase perfection, not profit, and the car they built forced Mercedes and BMW to reckon with what luxury actually meant. Click on that video and find out how they did it.